Swayam Prabha. Digital India. Educated India.
To understand the concerns of organizing engineering business and systems, one needs to have a clear-cut understanding of the determinants of technology strategy. You will obviously understand that it is not possible to be exhaustive or comprehensive in such an elaboration, but a lot of work has been done by people on this by way of research and analysis, and I would like to reproduce to you a diagram from Carey Salmon when in his writing on elements of strategic technology management at Acta Universitas Orleaniensis. He draws the following diagram for a clearer understanding of the issues. Let us walk through this in a manner where you are able to comprehend the determinants of technology strategy. The first determinant is internal forces, and we will move clockwise so that you can manage to grasp the basic elements. The second is the organizational context, where there is such a heavy interface amongst the concerns of engineering business and organization management. There is the market pull, there is the industry context, external forces, and technology evolution. This is very important because technology is never ever frozen, and if technology is never ever frozen, then one has to recognize that the basic assumptions being the same in the manifestation of technological forms, the upscalability is critical, which brings us to technology push. From technology push, we move on to strategic action, and that all converges on what is called technology strategy. These are the determinants of technology strategy, as it were. To take the discussion further, there are three phases of evolution of engineering and strategy. First is the science, which requires primary emphasis on scientific research. The relationship between science and technology is very often taken to be one of theory and practice. That is certainly a simplification, but for our purposes, one needs to come to certain generalized assumptions to take the argument forward. And to that extent, I think it is important to realize that the relationship to science and technology is much the same as it is between creativity and innovation, or between economics and applied economics. The fundamental research alone can help to establish the primary principles on which technology would be rooted, which is what has led to a chain of Indian institutes of science, education and research being established to the country, and this is a welcome move, because it helps to lay sounder foundations of technological growth. Technology is primary emphasis being on standardization, when science is principles of scientific research yield place to certain assumptions and paradigms, and they are put in a technological form, then standardization becomes necessary. From standardization emerges commercialization, where the primary emphasis is on commercial development and application. It is important to realize that what is technologically standardized does not necessarily have to be commercially viable. There are many commonplace examples and not so commonplace examples of this. Take for example, the slow permeation of gobar gas, or not so popular use of solar panels, because technically something was feasible, but commercially there seem to be all types of limitations in the use of, say, solar panels. If the roof is on a slope, it will not work. If the buildings adjacent to the structure where you want to put solar panels are of a height where the sunlight during the day is not as optimal as it needs to be, then the panels will not work, and ultimately it has to be more economical than other sources of energy. So, there are considerations which go into the commercialization of any technological innovation, and that is so obvious that there is no need to ham on that. This diagram, borrowed from Vistas M. Karbhari and James S. Burns and Dick J. Wilkins' work on total quality design and approach for customer satisfaction in critical advanced technologies, marks the relationship between science, technology and commercialization, because it shows the phases of technological advances, and the presentation there draws a comparative growth and dip profile of scientific research, technical development and commercial application. I do not think there is any need to elaborate on what is such a simple, but a clear diagram of a relationship which would exist amongst science research, technology development and the commercial applications. That brings us to the key dimensions of engineering business strategy. There are two components to which I would like to draw your attention to begin with. First is the product and the process mix. The use of a key engineering area decides products and also the process by which products are made. Perhaps the choice of the first is critical, because that determines the destination, but the precursor activity of getting those products out onto the market is equally important, because unless the processes are in place, the products will not be able to function in fully packaged form which are acceptable to the customer. Therefore, selection of the mix of engineering products and processes is important strategic decision. This selection of engineering products and processes is where the engineer needs to understand the compulsion of moving from being a designer of the engineering process to putting that process to productive use, and that, as I have earlier on also pointed out, is the bridge between engineering and management and how the two are in a complementary relationship. I would like to draw your attention to sources of engineering capability. The engineering capabilities can be developed internally through R&D, and which is why I am personally of the opinion, and there are many who would agree with me, that one needs to have a good R&D component in any engineering based organization. In fact, I am of the view that R&D is essential in any commercial organization, because R&D is not just related to products and processes, it is also related to knowledge management, it is also related to what applies to a firm, it is also related to how exogenous ideas may be adopted and adapted by the firm. Additionally, external sources can also be explored, and using licenses and privileged relationships with the academic or contract research organizations, vendors and users, one may push one's commercial interests further. The engineering portfolio requires setting of engineering products and processes in which the business unit has invested, combined with an assessment of the maturities of the component engineering, because there is an engineering cycle, and if you do not understand that engineering cycle, the set of engineering products and processes will be difficult to select in which you would need to invest. Base engineering is usually mature and do not provide a competitive advantage, because every other firm has the same access. Key engineering is critical to compete successfully. And finally, pacing engineering may replace the current key engineering and provide future basis of competition. Therefore, I would like to position this elaboration progressively on the need to understand competitiveness to survive in business. And your assumptions of technology and the way that technology is converted into an engineering outcome is important if you are to understand how we are going to piece together the different elements to make engineering business a viable proposition. There are levels of competence which are required to operate any framework. A business unit may choose to be a leader in engineering, or it may maintain a less advanced engineering capability, because the territory in which it operates is not a very demanding one. But to get this clearly, one needs to recognize that there are three factors that determine the choice of engineering business leader or the follower. The three choices are sustainability of the engineering lead, first mover advantages, and the first mover disadvantages. Because remember, I have pointed out earlier on that in the final analysis, everyone gets on to a similar kind of technology, and that does not provide too much of a breakthrough. The breakthrough comes essentially through the manifestations of managerial skills and post sales field engineering. Engineering business needs now to be considered sector wise, because engineering business has a different profile in small scale industries, in medium scale industries, and in large scale industries. Different territories of the world have different experiences in dealing with small scale industries, and in the projection before you, I will walk you through some important industrial zones of the globe, so that you begin to appreciate how the experience of engineering business in one part of the globe is not necessarily identical with the growth of engineering business in another part of the globe. Let us begin with Canada. Over 50% of the labor force works for small business. Japan, small business foundation on which the awesome industrial strength has been built. Korea, forged ahead with emphasis on large industry, now reversed its policy. Now, you have got three areas: Canada, where more than 50% of the labor force works for small business. Therefore, you do not get a very large number of mega firms originating from Canada. In Japan, it is a sequential relationship, be it automobiles, be it electronics, the components are supplied for the assembly units and the vendors do good business and the ultimate products also do good business. So, this has helped Japan acquire a very unique industrial strength. In Korea, the emphasis to begin with was on the large industry, but now it has been reversed. Around the core of small scale engineering business lies certain local interpretations. For example, in USA, one who discovers new ideas, organizes the business and manages the operations to provide economic goods and services for the public forges ahead. So, clearly you see there is a huge emphasis on new ideas, which really speaking in managerial terms converts one's own ability to ideate into innovation, and innovation is converted into a business opportunity, and business opportunity continuously needs to be upscaled. Therefore, new ideas are forever necessary, and patenting is huge sector in USA. In Germany, one with power and property is one who owns and runs a business. So, there is clearly a hierarchical dimension in Germany. In India, enabling, conducive, supportive environment by the government is necessary requirement. In fact, in very few parts of the world does the government play such a significant role in the growth of a given sector. So, government policies very often in India determine the trajectory of operations, which brings us to innovation as a concept in engineering business. The introduction of new products, new handsets, new PDAs, new iPods are good example, and I will through this presentation now try to focus on a given sector, so that the illustrations and the applications come out to you powerfully and help you to understand what is the larger principle which I want to emphasize. And that the sector of our choice will be telecom, but we will take a little while to get there. I was mentioning that introduction of new products, new handsets, new PDAs, new iPods, all taken as illustrations from telecom are the major propellers of engineering business there, which requires very often use of new methods of production. And indeed, opening of new markets. Rural telephony is a good example under reference, and this gets linked up at least in many developing country in many contexts of developing countries with equity and distributive advantage being made available to the deprived sections of the national population. So, there is always a heavy role for government to play in such an economy, but opening new markets has a large business dimension if there is profitability at the end of the tunnel. Conquest of new sources of supply of raw materials is forever necessary, because that also affects the material which goes into the making of the product. And if all this is put together, that is introduction of new products, use of new methods of production, opening of a new market, conquest of new sources of supply of raw material, then there will be an inevitable reorganization of any industry. Therefore, again one of the basic concerns for you to register would be that engineering business forever requires a redesign of organizations, restructuring of workflows, and a look at processing of information in a way in which competitive advantage is continuously being strengthened. One can look at in engineering business again in the small scale sector, but the attempt would be to go beyond innovation. The entrepreneurial effort in small scale engineering business makes decision often under conditions of uncertainty. Any small scale business has a relatively small R&D base. It will require multi-skilling. Its holding capacity will be definitionally low, and therefore, in the ultimate analysis it will be necessary to ensure that business keeps working before it can even consider risking, but then the closed loop principle starts operating, and in any case the inadequate database makes it necessary that the entrepreneurial firm operates under conditions of uncertainty. Now, if the endemic condition is of uncertainty, ability to take huge risks gets reduced. Thus, the entrepreneur will involve a determination of the types and degrees of uncertainty confronting the performance of a particular operation. Now, anyone who is in the small sector will have to be conscious of the uncertainty confronting performance, if not be specific in mapping it. The ability to make appropriate decisions are therefore necessary for goal attainment, which is where management as a discipline becomes hugely important for running of entrepreneurial firms. Example is the Newton PDA from the Apple failed in 1998. The engineering process in telecom, therefore, if taken as a case study, is illustrative of many of the observations which I want to make. First and foremost, growth of entrepreneurship in telecom requires early socialization process, making people aware of a new technology service, and then it can catch on like a forest fire. Launch of an SMS is a good example, but then what will catch on and what will not remains forever dubious, and that is the risk element in this sector, and other sectors would have their equally defining characteristics. Training and development of people to cater to changing needs of people and to the changing technology is important. One of the bigger hurdles in the optimal use of new handsets, say, in telecom is that there are not enough centers of orientation of people who acquire these instruments. Therefore, they are not able to use the value added services to the extent and to the intensity with which it may be in order. Then there are problems of environment, where regulation is forever chasing some stretching of the point which some business genius, and I use the word genius in quotes, has discovered, and the market. Now, coming in of the regulatory system then very often acquires limited success in mitigating the abuse, but can cause huge inconveniences to the people who are really law abiding, and that is a middle path with which any regulator will forever be concerned. The education system gets affected as the technology changes, as the business environment changes, and the skilled manpower needed to cater to the industry undergoes swift transformation, and telecom is a very good example. All this puts in place an urgent need to have an education component, a training component, an orientation component attached to all industrial houses, and this trend is gathering strength. But then the investment of this is very low. If you look around, the kind of investment which the telecom firms are making in executive education is not quite up to the actual requirements, because unlike an engineering shortfall, the disaster of a training or an educational shortfall is not all that dramatic. Opening of the economy and ease of movement of population and material has also made manpower planning in telecom somewhat complicated. The rate of attrition is high, people mobility is high, change of technology is high. Therefore, principles of redeployment do not quite work out with the same efficiency and with the same speed with which the system may be requiring it. A look at the factors which affect successful telecom innovation may help. First, of course, is capital, and angel investors, VCs, IPOs, secondary issues are some of the instruments for it. I have already talked to you about the skilled human resources of both technical and management talent. The important thing is to remember that technical and management talent does not necessarily come in packets which are discrete and are mutually exclusive, but some manpower would also be required for techno managerial talent. There is the need for continuous research, and I have already pointed this out. There is a need for newer designs, especially when it comes to handsets, and above all, the investment and tax climate has to be favorable. If tax climate is not sensitive to entrepreneurial propositions and what causes the growth of business and what causes its decline, then investment is going to be affected, and if investment is going to be affected, then growth of engineering business is going to be affected, and this is the whole business of market forces which have to be understood, for which again management education is a must. This particular course will not be very helpful to you in understanding an entire domain of expertise which affects market operations, and for that you may need to take up courses in marketing. But please remember, this course is an introductory course more focused on causing awareness of what you need to know to be successful, rather than give you all the capabilities which are required to run engineering business successfully. And finally, government policy and intervention mechanisms are the key determinants of the growth of the telecom sector. Whether you call it liberalization or you do not call it liberalization, the principle is simple. We cannot wish away the government, because the government is going to be a player in all operations, because the policy dimension of a sector like telecom has to do with intergovernmental relationships. So, in certain ways there are areas in which the role of government has actually gone up rather than gone down, and this is important to understand. Straight-jacketed understanding of the market, straight-jacketed understanding of governmental policy, forward understanding of simple investment does not work. Investment complexities vary from sector to sector. The requirements and the returns in telecom sector are certainly not those of what come in textile. The market forces in operation in telecom are also unique, and as I have just stated, the government policy also becomes a remarkable player. So, engineering business has few generic dimensions, but it has also a few context specific elements, and you should be able to follow it all. The engineering business entrepreneur in telecom would have 6 major tasks. He must understand exchange relationship. Exchange relationship not in a human relations sense, but in terms of the exchanges of the subsector in telecom, say switching to transmission to customer interface in terms of the material instruments which the customer uses, and finally field engineering. These exchange relationships will work only if you have an appreciation of what the previous subsector is doing. Then there is the need to focus on practical administration. There are no laws on how to administer a telecom industry. It will have to do with the scale, it will have to do with the subspecialization in which the firm is placed, it will have to do with the kind of investment which has taken place, and above all it would depend upon the supply chain management under which that sector is operating. This in turn affects management control. When we were talking of understanding organizations, we talked of a very large number of choices which are there in terms of management control. It is best to understand those management styles and organizational forms, not with a value judgment of what is better or what is wrong, but more from the point of view of how it works. So, that is what is meant here as management control. Then the technology. All technologies do not work everywhere in the same manner. At times, a technology may be embedded in an environment which basically believes in repair as an instrument of maintenance. If, however, the technology has originated in an environment where use and throw principle operates, it will be a different kind of technology. Now, this is something which very often is not kept in mind by firms which either design a product or when they are marketing a product. But believe me you, these considerations do affect the survival of the product. A culture which is used to repair technology to keep an instrument going will never be comfortable with a product which is from an industrial environment of use and throw. These four elements therefore, exchange relationships, practical administration, management control, would affect risk taking. Risk taking is an important characteristic of any firm. Very often risk is seen in financial terms, but risk can take many forms. Risk today is perhaps most endemically available as a security risk. Almost nothing and nobody seems to be safe without taking the basic precautions. And I am not just referring to physical safety, I am also referring to the kind of risk which is inherent in online dealings in terms of new ways of payment and deposits. There are huge risks there and the perfect system has not been devised. So, each investor, each person who is operating a system will have to define risks for himself and position himself in a manner where vulnerabilities are low and the risk taking is not one which will undo the entire system. And then of course, inevitably it ends on innovation, because innovation would cut through all these phases. Innovation remains a different way of doing something which is more elegant, more economical and less time consuming, and of course, less resource consuming, and that is the definition of innovation. I would like to walk you through each one of them in a manner where you will find it is simpler to appreciate their nuances, but let us first focus on exchange relationship. Exchange relationship has to do with perceiving opportunities in the market. The best example I can think of is the way Vodafone opened into India. The second is gaining command over scarce resources, and the example which comes to my mind is the way Reliance operates. Then there is the exchange relationship of purchasing inputs, and in my judgment, China is a good example of purchasing inputs. The dimension of marketing of products and responding to competition is again an exchange relationship, and Airtel comes to me as a good example of this. Size of course is a factor of competitive advantage or disadvantage, and since the reference was earlier on to small firms, let us look at what are the advantages for small engineering business firms in telecom. The advantages is it employs more generalists than specialists, and generalists are more easily available. It is easier to develop and sustain enthusiasm for the company in a small business firm, and it applies to a small engineering business firm. In a small firm, there are no constraints imposed by high investments and in current technology. It is therefore more flexible. But there are disadvantages for small business firms in telecom too. One is lack of capital for investing in risks. The second is lack of promotion opportunities at higher level, preventing top class men from joining the firm. The list can go on, but I would like to now walk you over to the opportunities of small firms in engineering business. Small firms in engineering business would have large opportunities in information and communication technology related industries. This includes computer and software, it includes computer related services, it includes telecom equipment and services, electronic micro components and office components. In content related industries, small businesses will have a huge potential in publishing, audiovisual and in advertising, and obviously you can make out that this list is neither exhaustive nor limited. So far as telecom specific factors are concerned, for growth you need technical innovation, you need to flag the declining costs and work around it, you need to recognize the internet explosion, you need to recognize the principles of e-commerce, and you need to understand multimedia. Now, in these elaborations, 5 of them I have tried to focus your attention on telecom specific factors which affect growth. In other words, each sector will have its own defining characteristics of growth, and for limitations of time I have chosen just telecom to illustrate to you how the system would actually work. Let us move on to the action areas. The action area involves promoting organizational change, boosting skills and developing an enterprise culture. Now, this is more generic in character, this can be found almost anywhere. When you apply it to telecom, then let us go back to the preceding slide. It would cover the 5 areas which I have outlined here. So, you apply these 5 areas into this diagram and you position the 5 areas here at the center of the what appears an a triangle which has equal weightage to all sides, and you have the diagram complete. The action therefore is needed in developing enterprise culture, and that is the management component which we will be focusing more, not only in the treatment of this topic, but other topics in this course. How do you develop an enterprise culture? You create an environment in which new ideas, new startups, new products and new services can flourish. What I am trying to put across to you is your practices would continuously need to be upscaled, your practices would continuously need to be improved, your practices would continuously need to be refined through innovation if you want to develop an enterprise culture which is competitive. Promoting organizational change and adaptability is equally important, because please remember, organizations are organismic entities. They have a life cycle. They are born, they grow, they at times undergo entropy and therefore, again go back to growth after overcoming the constraints. There are crests and troughs, they have a life cycle and they all die. So, if organizations are organismic entities, promoting organizational change and adaptability is part of the learning process of an organization. To exploit the full potential of the new technology, to improve efficiency, develop new products and all services, and unleash the creativity and innovation of the workforce, you need to promote an organizational change and adaptability culture, which means that all ideas would be welcome, any idea is worth trying out once, and idea leadership is duly recognized. To sum up this component of the action plan, it is important to emphasize that you need to boost skills and levels of technical literacy, both within the organization and amongst the users of the system. And in telecom area, there are evidently large gaps in sensitizing the user system to the technical literacy, which helps the optimal use of the technology. What are some of the hindrances in this situation? The hindrances would be a strong entrepreneurial culture being absent. Therefore, hierarchy takes place, bureaucracy starts calling the shots and nobody really gains. This is a hindrance which needs to be overcome. Couple this up with the absence of market incentives with which many taxation systems do create. This discouragement of initiative is a huge impediment in growth of engineering business, and the management culture which goes with it will have to factor this in. The legal and administrative barriers to the creation of companies and the introduction of new products and services are formidable in several developing countries, and those countries which have leapfrogged to development, it has been largely because they have been able to handle the legal and the administrative barriers to growth. Here again, corruption is a huge factor, because corruption would flourish on the kind of legal and administrative barriers which can be created. Therefore, there are systemic propositions which need to be handled at an operational and an administrative frame in a proactive manner before engineering business can grow. There are other problems like shortage of power, problems of finance, raw materials, human resources, technological changes, marketing and managerial inadequacies. I am sure you have heard of all this before, and in fact, this has been repeated so often that one has almost got immune to either understanding it or doing something about it. That does not take away from the fact that the shortage of power, the problem of finance, raw material, human resources, technological changes do continue to be important hindrances in growth of engineering business, and no business can grow if these impediments are not removed. Business what really needs is simple, rapid administrative solutions, such as one-stop shops with formalities and procedures standardized across agencies and member states, member constituencies, all the stakeholders. In fact, in my limited experience of consulting and research in this area, I have come to the conclusion that even a simple step of alerting the respondent to all that is required and all the questions which can be asked prepares him to handle better, and it does not become one question at a time, he rushing back to find an answer to that question and coming back with the answer to be raised yet another question, and that makes it really a complicated process.